All right. So we are going to continue talking about quadrilaterals. We've got two more types of quadrilaterals to cover. We have trapezoids and kites, and today our focus is going to be on trapezoids. So a trapezoid is a quadrilateral. What does quadrilateral mean again? Shape with four sides, thank you. A quadrilateral with one pair of opposite sides parallel. So when we're talking about a trapezoid, the sides that are parallel, like DC and AB on this trapezoid here off to the right, the parallel sides are called the bases. And we usually refer to them as base 1 and base 2. It does not matter which parallel side you call base 1 and which parallel side you call base 2, but one of them is base 1 and the other one is base 2. The other two sides we just refer to as legs. A mid-segment of a trapezoid is a segment that connects the two midpoints of the legs. So first you would identify the midpoints of the legs, so the non-parallel sides. So this would be a midpoint here. And over on the other leg, this would be a midpoint here. And so then the mid-segment connects those two, and the mid-segment is parallel to the two bases. To find the length of a mid-segment, we have a formula. The formula for the length of the mid-segment is mid-segment equals half of base 1 plus base 2. Mid-segment is equal to half of base 1 plus base 2. All right, we are getting ready to find the length of a mid-segment and the length of a base using the mid-segment formula. All right, so let's look at number 2 now. In the figure, UR is the mid-segment of trapezoid PQST. Find UR. So the formula said the mid-segment is equal to 1/2 base 1 plus base 2. The name of the mid-segment is UR, so I'm going to put UR in the place of where it says mid-segment, equals 1/2, and then we need base 1 and base 2. How big are bases 1 and 2? 11 and 18. Here's base 1. Here's base 2, so we do 11 plus 18. What is 11 plus 18? 29. So UR is equal to 1/2 of 29. What is 1/2 of 29? How much? 14.5. Number 3 is a similar problem, except what are we looking for on number 3? We're looking for X. Is that a base or a mid-segment? This is a base. Let's go ahead and call this B1. So what would this 24 be then? That's the mid-segment. And 16.7 on the bottom? That's base 2. All right, so our formula is mid-segment is equal to 1/2 base 1 plus base 2. How big is the mid-segment? 24. So in the place of mid-segment, we're going to replace that with 24 equals 1/2 of, what are we putting in for bases 1 and 2? X plus 16.7, yes. All right, so the very next thing we need to do is deal with this fraction that's out in front of the parentheses. What operation undoes fractions? Multiplication. And what part of the fraction do you multiply by? By the denominator. What's on the denominator of this fraction? 2. So I'm going to take this whole side. We're going to multiply it by 2. We're going to do the same thing over here. We're going to multiply by 2. Over on the right, the 2 that I'm multiplying by and the 2 in the denominator cancel out. And so then I take the numerator, which is just a 1, and I distribute that. Over on the left, we have to do 2 times 24. What is 2 times 24? So 48 equals 1 times x, which is just x, plus 1 times 16.7, which is just 16.7. So the first thing we do is we get rid of the fraction by multiplying by the denominator. That cancels the denominator out, so we don't have a fraction anymore, and you distribute the numerator inside the parentheses. Then we're going to subtract 16.7 from both sides. And that would give us what for x? 31.3 is the value for x. Nicely done. go look at number 4 now. This is a special type of trapezoid. This is an isosceles trapezoid. What is an isosceles triangle? Two of the sides are congruent, yes. Same thing is true for my isosceles trapezoid. This is a trapezoid. With congruent legs. So there's that 2 congruent sides. So in my picture here, this would be a leg. This would be a leg. Those are the pieces that are congruent. We have base 1 up on top, which is parallel to base 2, which is on the bottom. So we're going to talk about the properties of an isosceles trapezoid, the properties of the legs, the diagonals, the base angles, and the non-base angles. The legs are the slanted, non-parallel sides. And those are congruent. The diagonals are congruent, but unlike parallelograms, they do not bisect each other. We talked about 4 special types of parallelograms that all have these bisecting diagonals. Talked about rectangles and rhombuses and squares, and then just parallelograms in general. And those diagonals bisect each other. Here the diagonals are the same length, but they are not bisecting. The base angles are congruent. So these 2 angles down here would be considered base angles because they are both touching the base. How many bases do we have on this trapezoid though? We have 2 bases. So these 2 angles up here that both touch base number 1 are also considered base angles. The base angles are congruent. The non-base angles, so if I were to pick one angle that touches base 1 and one angle that touches base 2, those are supplementary. So base angles are congruent. Non-base angles are supplementary. Let's look down at number 5 now. It says, given isosceles trapezoid WXYZ with ZW equals 12. Let's add that to the picture. ZW is equal to 12. ZX is 26. We need to draw in ZX because it's not in the picture. ZX right here. is 26. ZY is 22. So up here is 22. And finally, XW is 35. All right, so we're going to use that information along with the 109-degree angle that is printed there for angle Y to answer the following questions. So we know this is an isosceles trapezoid. What are the bases? Which sides are the bases? Which ones? YZ and XW, so the 22 and 35, yes. This is a base. We'll call that base 1. And down here is a base. We'll call this base 2. What's special about an isosceles trapezoid that's not true about just any old regular trapezoid? The legs are congruent. How big is the leg here? 12. So what's the other leg? And what is the name of the other leg? YX. YX is 12. ZW is 12. Is that one of the questions that was asked? Where's it at? Top or bottom row? Bottom, right there in the middle. This is a leg. And we know that that is 12. All right, they also want me to give the measure of angle Z. Angle Z is right over here. Is this a base angle? Yes. What would it be congruent to? Angle Y right here. Those both touch, excuse me, those both touch base number 1. If they touch the same base, then they are base angles. So angle Z is 109 degrees. Now we want angles X and W. What do we know about angles X and W? I don't know how big they are right now, but what do I know about them? Yes, they're base angles. They both touch base 2, and that means they are congruent. So let's mark them as congruent. What did we say about non-base angles? They're supplementary. So what would I need to do to find angle X? Subtract from 180. We're going to do 180 minus 109. And that would give us what? 71. So 71 degrees. So how big is angle W? 71 degrees. Angles X and W are both the same size, 71 degrees. All right. This angle right here is 109. We've got 2 things left to find here. We need the measurement of YW. Well, what is YW? I know it's not drawn in, but what part of this trapezoid would YW be? It's a diagonal. It connects opposite corners. What do we know about the diagonals in an isosceles trapezoid? They are congruent. They don't bisect each other, but they are congruent. So do we know how big YW is? How big? 26. All right, the last thing we need is the mid-segment. How do we find the mid-segment? Yes. Mid-segment is half of base 1 plus base 2. How big is base 1? 22. Plus base 2, how big is base 2? 35. So we need half of 22 plus 35. That would be half of what? What is 22 plus 35? 57. So I need half of 57. What is half of 57? 28.5. Nicely done. Let's flip the page over to page 11. Given isosceles trapezoid, RSTU, which has mid-segment HK, ooh, is this on the picture? What do you think we need to do then? We're going to add it. We're going to draw this on the figure. So H is going to be on one of the legs, and K is going to be on the other leg. And then we're going to connect those two. If that's the mid-segment, then SH and HR are congruent. TK and KU are congruent. But what do we know about these two legs? What do we know about SR and TU? They're congruent. So that means that TK is the same size as SH and HR, and KU is the same size as TK, SH, and HR. Are the bases congruent? The bases are not congruent. The bases are parallel, though. Bases are parallel, and the mid-segment is parallel. All right. Let's look at part A now. It says if HK is 6x minus 13. So I'm going to add that to my picture. 6x minus 13. RU is 5x plus 24. RU down on the bottom. 5x plus 24. And ST is 48. So up on the top is 48. Find the value of x and the length of RU. So 48, excuse me, would be base 1. 5x plus 24 is base 2. And we have our formula for the mid-segment. The mid-segment is equal to 1/2 times base 1 plus base 2. All right, so let's substitute in what we know. What is the mid-segment here? 6x minus 13, yes. So I have 6x minus 13 equals 1/2 times, how big is base 1? 48. Plus base 2, how big is base 2? 5x plus 24. All right. We are going to solve this for x. So there's a couple things that we can do in this first step. Inside the parentheses, I'm going to combine my two constants, my two numbers that don't have x's. At the same time, I'd like to get rid of the fraction that's on the outside of the parentheses. What operation gets rid of fractions? Multiplication. And what part of the fraction do you multiply by? By the denominator. So over here on the right, we're going to multiply this entire side by 2. And that means over on the left, we also multiply that entire side by 2. Make sure that you are putting either parentheses or brackets around the entire left-hand side. So on the right, the 2 and the denominator will cancel. The 1 distributes to everything inside here. Over on the left, the 2 is distributing inside those brackets. So I would have 2 times 6x, that gives me 12x, minus 2 times 13, so minus 26, equals, and then over here on the right, I have 5x, and then I'm combining my like terms together. What do you get when you combine 48 and 24? 72, so 5x plus 72. What do I want to do now? Subtract 5x from both sides, yes. So that's going to cancel out. Over on the right, what is 12x minus 5x? So I have 7x minus 26 equals 72. What now? Add 26 to both sides. What do you get when you add 72 and 26? 98. So 7x equals 98. Then we're going to divide both sides by 7. And that means x is what? X is 14. We still need to find the length of RU. RU is 5x plus 24. And we just figured out that x is 14. So 5 times 14 plus 24. What do you get when you do 5 times 14 plus 24? Yep, 94. We get 70 plus 24, which gives us 94. All right. One more part of this question to answer, and that'll wrap us up for the day. It says the measure of angle S is 117 degrees. So I'm going to go add that to the picture. S is 117 degrees. What other angle would have to be 117 degrees then? Angle T would also have to be 117 degrees. It says the measure of angle R is 3A plus 15 degrees. So down here is 3A plus 15 degrees. We need to find A. Well, what do I know about non-base angles? They're supplementary. The measure of angle S plus the measure of angle R equals 180 degrees. So I have 117 plus 3A plus 15 equals 180. We're going to combine our two like terms together. What do you get when you combine 117 and 15 together? 132. So 3A plus 132 equals 180. Then we subtract 132 from both sides. What is 180 minus 132? So 3A equals 48. Divide both sides by 3. And A is what? A is 16. The last thing we need to do is find the measurement of angle U. What do we know about the measurement of angle U? Yes, it's congruent to the measure of angle R. So it's 3A plus 15. So we would do 3 times 16 plus 15. What does that come out to be? 63. Beautiful. that wraps us up for today. The new homework you guys picked up on your way in the door is due on Friday. New homework is due on Friday.